Alrighty, we are going to start chapter 3 today. I still have a couple of you that owe me the test. So get in and get that taken as soon as possible. Before we go on, I do need to pass this out. Do not lose this. This is something you'll use quite a bit in the next little while. It's two-sided, it's on cardstock. It's bright pink. So, alrighty. On the side that you should be getting, that's a list of polyatomic ions. We will discuss them. We will probably not get to them today. You'll have to memorize like 6 of them, or write them on your 3x5, whatever. The back's an entire flow chart. We'll get to that as well. Again, we'll not get to that today, but I wanted to get these in your hands right now so that we would start to familiarize yourself with them. Alrighty, so and there's a problem with YouTube. It's not letting the district upload right now. So I have last year's videos up already, but nothing from this chapter's up there yet. So try to get on. You can watch last year's stuff, but not this year's stuff yet. Alrighty, so it is 10. Is it the 5th today? Yeah, my watch says the 21st. I don't think that's right. Alrighty, so we got a straggler today. Nope. Alrighty, 10, 5. Oh, is there a bunch there?
Just 3.
Does anybody know her name?
It's Peyton.
Peyton?
Yeah. I'm crying.
Alrighty. Chapter 3 is a lot like chapter 2. Not a lot of math, but a lot of stuff you just got to know. So yeah, we'll see what happens. So it is Chem 11:10, chapter 3, day 1, and our objective is going to be able to better understand ions and ionic bonding. Now, who can remember what an ion was? We talked about this a little bit last chapter. There was a question on the test on this. Anybody remember what an ion is? What? It's a charged particle. Okay, it's a charged particle, but how did we talk about that? She's right, but we went a little deeper than that. Yo, Strat.
If they like gain electrons, become an anion, and if they lose them, they become an anion.
Alrighty, so an ion is basically an atom that has gained an electron and become an anion, or lost an electron and become a cation. Now, traditionally, metals are cations. Okay? Non-metals are anions. Okay? This is when the steps become really important. Who knows what I mean when I refer to the steps? Yeah, I'm talking about the steps right here on the periodic table, right? Everything to the left of the steps, okay, loses electrons and become cations. everything to the right of the steps gain electrons and become anions. Okay, so make sure we understand that. Now, what's going to happen, and this is pretty much the way, 70% of the bonding in the world goes. Okay, ionic compounds. Okay, an ionic compound is formed by the transfer of electrons. Okay, now this is what's going to happen. I'm going to kind of walk you through an example. Now let's take aluminum. Okay, now aluminum has a valence of what? Can you tell me what the valence of aluminum is? 3, right? It has a valence of 3. I got 3 dots here. Okay, what's the valence of chlorine? 7, right? So now what happens is chlorine gets near aluminum. Chlorine says to itself, self, if I had one more electron, I would have a what? Anybody remember what chlorine would like to have? It starts with an O. Anybody know? Anybody took chemistry wants to have an octet? It's called the octet rule, which means each atom would like to have a valence of 8. Okay? Because then it'd be just like a what?
Noble gas.
A noble gas. What do we know about noble gases? Anybody know anything about noble gases? They're stable. They don't react. Why don't they react, Sydney? Because they already have a valence of 8. They're happy. If you think back to the olden days, the nobles were the rich people. They were always happy. It was the peasants and the serfs that were unhappy, right? Now, what happens is chlorine looks at aluminum and says, you know what? I'm going to take one of your electrons. And it does. Okay, and it does that. Now this chlorine right here technically becomes what is known as Cl negative. And it's now happy. But now it's an ion. And ions are more reactive than elements. Okay? Now, aluminum now has 2 valence electrons. And it's thinking to itself, you know what? If I got rid of those 2, I would then have a valence of 8. Because once those 2 are gone out there, now I've got 8 in my last shell. So what do you think happens? Anybody know? Now the chlorine comes along. And that other chlorine also has a valence of 7, and it takes another one. It takes one more electron, and then I get another chlorine coming along, and it does what? It takes that last electron. Okay? What you end up with is you end up with Al3 positive, and you end up with Cl negative. Hey, this was in the stack. That's not in this class, though. I tried to catch her, but she was gone.
Okay.
Just give them their first
Riley.
name.
And Rosalia.
It's not what you go by, though, right?
Yeah, it's the left.
Yeah, there you go.
Yeah.
Okay. Now, what happens is you end up with something that looks like this. Now, granted, we already realized there were 3 of these, Cray, because we had those 3 right there, right? And I get there from what is known as drop and swap. Okay, and what that means is this. I take that, I write it there, and I take that, and I write it there. And what am I going to end up with? Anybody want to take a stab at that? Nobody? I'm going to end up with AlCl3. and this is known as aluminum chloride. And that is an ionic compound. Okay? Now, ionic compounds bond based on the cancellation of charge. Okay, and what that means is this. If I go back and I look at my AlCl3, right? Now, we started with Al3 positive and Cl negative. Okay? Now, in order for these to get together, the charge, right, must cancel out. What do you think that means? Anybody know? Yeah, Stratford.
They have like a positive for each negative.
Yeah, so if this is a 3 positive, I've got to have a 3 negative, right? Well, the only way to get a 3 negative if it's only a 1 negative is to times it by 3, which is where I get that 3 right there. Okay? So I have one of these, which gives me a net 3 positive. I've got 3 of those, which gives me a net 3 negative. Those charges now cancel out, and I end up with AlCl3. Okay? You give me the look. No? Okay. All right. Now, what happens is this. Is you can do this with any compound out there. Okay? So like, let's say I take calcium and I take phosphorus. Okay? Now, where's calcium at on the periodic table? It's in group 2, right? Okay? Which means it has a valence of 2. So what do you think is going to happen? What's it going to do with those 2 valence electrons? It's going to get rid of them, right? And it's going to become Ca what? 2 positive, right? Phosphorus has a valence of what? 5, right? Now, if it's got a valence of 5, it can do one of 2 things. It could gain 3 electrons, or it could lose 5 electrons. What's it probably more likely to do? Yeah, gain 3, right? So it's going to gain 3, and it's going to become P what? 3 negative. Okay, based on the whole drop and swap here, what am I going to end up with? Nobody can do that? Ca3, P2. And this would be called calcium phosphide. Noticing all anions end in "ide." Okay, they're going to end in "ide." Always the second one. Okay. Now, let's say, let's go here. What we're going to do today is we're going to talk about 2 different things here. We're going to talk about what are known as, that's supposed to be a P, not a B. We're going to talk about what are known as type 1 binary ionic compounds. Okay? And then we're going to talk about type 2 binary ionic compounds. Okay? A type 1 binary ionic compound is when you have a metal with only one oxidation state bonded to a nonmetal. A type 2 binary ionic compound is when you have a metal with more than one oxidation state bonded to a non nonmetal. Okay? So type 1 binary ionic compound and type 2 binary ionic compound are very, very similar. Okay? Now, back in the olden days, like 2 years ago, we used this periodic table as a class. And it was really, really good. Okay? And let me explain something. So everybody look right here at strontium. Now, I know you can't read it, and I can't zoom in like I used to. But right above strontium is a little tiny 2. Okay? That is what its oxidation number is. Okay, well, it's also its what? It's also its valence, right? Now, I know that strontium is going to take those 2 electrons and lose them, right? And it's going to become Sr2 positive, okay? All the elements in group 1 become a 1 positive. See how I've written that right there? All the elements in group 2 become a 2 positive. Okay, they only have one number above them. Once you get out here, now you've got type 2s. Because look at ruthenium right here. You can't read that, but above ruthenium it's got a 2, a 3, a 4, a 6, and an 8. Which means it could be any of those numbers. Okay? Ruthenium then qualifies as a type 2 binary ionic compound. Okay? Now, Baker, right?
Yeah.
If you look just to the right of the symbol, the second row down, and look at ruthenium, what numbers are there? Yeah, it's number 44, I think.
Yeah, so I'm looking at it now.
So just to the right of the symbol and below it, there's a number, and then there's a set of numbers.
Okay, so there's like 132 and then 2, 3, 4, 6, 8.
Yeah, okay, so that are the options for it. Okay, so it gets a lot more difficult. Now, what happens is there's like 11, aside from these two, I think there's 11 elements over here that only have one oxidation state.
I got one more for you. Hallie, Roundy.
Okay. So what happens is they'll be type 1 and the rest will be type 2. Now I know that these two are type 1. Most of these are going to be type 2. What I'm going to do is I'll go through the test and tell you which one of these you just have to know. Okay, is that like right now?
Yeah.
Like
That's taking notes for you.
what?
That's taking notes for you.
Well, you know, I have a video of this, right? You just go watch it.
I'll be back
Okay.
ASAP.
Okay. In the future, it's, hey, Mr. Denton, I got to get out of jail free card. Can I go? Or whatever. Not that you'd ever think my class is jail. I saw that grin on your face. Yeah, and I could see you smile to that. I see how it is. I'll remember that. Now, so what happens is in a type 1, you simply name the first ion and you name the second ion and it ends in "-ine". They're easy. When you get to type 2, now it becomes a little more difficult. Okay? For instance, let's say I look at iron. Let's say I want to combine iron and I'm going to combine it with chlorine. Okay? Iron and chlorine. Now, if I look at the periodic table, so Baker, you look over at iron. Okay, iron's number 20-something. It's a Fe, right?
Yep.
What are my options for iron?
2, 3, and 6.
2, 3, and 6. Now, once it gets above a 4, don't worry about it. It's going to be one of the ones below a 4. Okay? So iron can be a 2 positive or it can be a 3 positive. Okay? Chlorine is always going to be CO what?
Could you slide down a little bit, please? Thank you.
Anybody know what chlorine will always be? It'll always be a 1 negative. Okay? Now, I do the whole drop and swap here. Okay? And the top one would give me what?
FeCl2.
FeCl2. What would the bottom one give me?
FeCl3.
FeCl3. Now, are they different? Yeah, vastly different. Like vastly different. Okay? Now, the question becomes is how will I tell them apart? Well, if you had a sample of them, they would look different. They're going to be a different color. They're vastly different. But to name them, this is what happens. You use a Roman numeral to signify that charge. So this one would be known as iron 2 chloride. That Roman numeral indicates that charge. So what do you think the second one's going to be? It is iron 3 chloride. Now notice what kind of number I use there. Roman numeral. Why do you think I use a Roman numeral? Who was that? Celeste, why do you think I use a Roman numeral?
I don't remember.
You don't remember?
No, I just remember that they were Roman.
Anybody want to take a stab at why it's a Roman numeral? So you don't get it confused with how many there are, right? I can't tell you how many of you on the test are going to screw this up. You're going to think that that Roman numeral means how many irons there are. It's not. It is the charge on the cation. Okay? So the Roman numeral, and I'm going to write this down. This is 6, right? Okay, so the Roman numeral is the charge on the cation. Okay? So let's say I did this. Let's say I gave you this. Let's do this. Let's say I gave you Ni2O3. Okay? Now, and let's say I wanted to come up with a name for this. This is its formula, and I want its name. Now, if I look at nickel, so Hannah, now you're up. Look at nickel. It's like 26 or something. 28 maybe. Okay. Look at nickel, and do you see those two little numbers down to the right of its symbol?
Yeah.
What are they?
2 and 3.
So I'm either nickel 2 positive or I'm nickel 3 positive, right? And that's important because that's going to dictate what its name is, right? Now, how do I figure what it is, whether it's a 2 or it's a 3? Anybody have any idea? Okay, okay, I can sometimes. That doesn't always work, and we'll talk about that in a minute. But what I do know is where's oxygen at? What's oxygen's valence? It's a 6, right? So what does it want to do? It wants to gain 2 and become O2 negative. Okay, now oxygen is what I call a 99%er. Okay? Which means that oxygen is going to be a 2 negative 99% of the time. There's only one exception, and we don't ever talk about it. You see oxygen, you know oxygen's a 2 negative. Okay? Well, how many oxygens do I have? I have 3, which means what is my net negative charge over here? Isn't it a net 6 negative? Right? If there's 3 of them, each of them are a 2 negative, doesn't that give me a net 6 negative? Well, what does that mean my nickel has to be? But it has to be a net 6 positive, right? Well, if I've got 2 of them, each one must be a 3 positive, right? So when I name this, I would name this what? Nickel. No, it's each. Nickel 3, because that's its charge, not how many there are, it's its charge. Nickel 3, then how do I write the anion? They're always an oxide. Nickel 3 oxide. Now let me share an example of why you guys need to understand this. Let's say I take 2 things. Okay? Now these are covalent compounds, but they bring up a really good point. How close are these two things in their formula? I mean, they're off by 1 oxygen, right? Just like the FeCl2 and FeCl3 we did, right? Now, what is this? Carbon dioxide. Does anybody know anything about carbon dioxide? Wow. No one in here knows anything about carbon dioxide. I find that hard to believe.
Breathe it out.
We breathe it out. Okay, is carbon dioxide important?
Yes.
Why?
Plants breathe it in.
Starts with a P.
Photosynthesis.
Oh, little thing called photosynthesis. I don't know about you, but I think it's kind of important. Who can tell me why photosynthesis is important? Oh, what? Oh, it's how we get oxygen, which is like one of my favorite elements because I like to breathe, right? So yeah, carbon dioxide is important. What about this?
Is that carbon monoxide?
Oh, it's carbon monoxide. Do you know anything about carbon monoxide?
You don't want it.
You die! Which would not be good. So one is vital for life, and the other one kills you. And all we have changed is 1O. Kind of important, right? So yeah, you got to make sure you understand what this stuff is. Now look, this is really, really easy. Now, who went backwards? Who did drop and swap the other way? Was that you, Buxton? You did it backwards? Now, that works sometimes, not all the time. This works all the time. Let me explain. The reason it only works sometimes is, let's say I take, let's say I want to put calcium and oxygen together. Calcium and oxygen, right? So that's a Y. Calcium and oxygen. Okay, what do I know about calcium? What's calcium going to be? 2 positive. What's oxygen going to be? Right? So when I do my old drop and swap, what am I going to get? I'm going to get Ca2O2, right? What will happen if you put that as an answer? Anybody know? You'll get it wrong. Anybody know why you would get it wrong? Nobody? Because this is like a fraction. If you had me for math, a fraction that is not reduced is wrong. So what would the answer really be? CaO. So now if I go backwards, it doesn't always work. But that is a good idea. Does that make sense? Okay. So let's do this. Let's go raisey handy. Let's see if anybody in here is smart enough. Okay. And I want to do, let's just do this. Let's say I put calcium and bromine together. Okay? Bromine together. I want the formula and the name for what calcium and bromine is going to give me. Okay? I want you to write the formula and its name. And let's go for 5 hands. We'll start off real easy. I need 5 of you. Hopefully I got 5 smart people in here that can figure out the formula and the name for calcium plus bromine. You guys all have a periodic table, right? Get your freaking periodic table out so you know which column it's, or which group it's in, right? So if I know which group it's in, I probably should be able to figure out it's what? It's charge, right? Come on, 5 hands. 1, 2, 3, 4, 5. Alrighty. So who was 4? What do you got for me? Give me the formula first.
CaBr2.
CaBr2, is he right? That's what I got. And what's its name?
Calcium 2 bromide.
Calcium 2, Roman numeral 2 like that, bromide? Is that right? No. Why is that not right? Sydney, why don't I need a Roman numeral? Exactly. Remember that the Roman numeral only falls into this area, and it's only about 75% of them. Calcium is a group 2 metal. Group 2 metals only have one number above them. They do not need Roman numerals. So what it's going to be is this. These two groups will never use a Roman numeral. These are 75% rule they will. I will give you a list of ones to know that do not need Roman numerals. I'm going to go back through the test and see which ones they use, and they're the ones we'll memorize. Well, they're the ones you'll write down on your 3x5. Let's be honest here. I mean, you know I'm right? Okay. I'm a realist. It's okay. Okay, let's do this. What if I give you the name and see if we can go... Didn't want that pen anyway. And see if we can go backwards. Give me the formula. Let's do that. Let's do this. Let's go. I'm going to give you this. I'm going to go palladium 4, IV Roman numeral 4, nitride. Palladium 4, nitride. Okay? Let's see if you can give me the formula when I give you the name. Now, what do I know already? The palladium's probably going to be.
Type 2.
I know it's a type 2, but where's it at on the periodic table so I don't have to spend forever looking for it? It's probably a transition metal, right? Because that's that area that required a Roman numeral, right? Let's go for 7 hands. Palladium's number 46 if you can't find it. One. Two. What did I say? 7? Yeah, 7. I'm at 2. I need 5 more. 3. 'People, this should not be this difficult. Everybody watch. Well, let's do this. Corinne, you want to tell me what you have? PD big N4. She's close. Now look, all I got to know is palladium 4 tells me that it was PD what? 4 positive, right? I know that. Well, Where's nitride at? Nitride comes from nitrogen, right? And it has a valence of 5, which means it's going to do what? It's going to gain 3 and become N3 negative, right? So what's missing from this? PD 3 and 4 when I do my whole drop and swap. Is that making sense or no? I'm getting lots of starry-eyed looks here. Yes or no? Yeah? Should we do another one? Let's do this. Let's go with nickel 3 oxide. Nickel 3 oxide. And let's go with 7 hands again. One, 2, 3, 4, 5, 6, 7. Alrighty. Duel, what do you got?
N2O3.
And 203. Isn't it Ni?
Oh,
Ni 203. Nickel, not nitrogen, right? Is she right?
Yeah.
Just like that. Now, what if I did this? Let's go nickel 2 oxide. What? I don't know. You're gonna ruin my Razy Handy Gamey, Buxton. Is it NiO? Yeah. Why? Because nickel 2 gave me Ni2 positive. Oxide gave me O2 negative. But when I drop and swap, I have to reduce. Ni2O2 gives me NiO, which is why you always can't work backwards. Okay? Alrighty, so let's do this. Let me give you... Oh, I'm going to give you the formula, you give me the name. Okay? Let's do that. PTO2. That's its formula. I need its chemical name. One. Let's go for 10 now. 2, 3. Got to get to 10. 4, 5, 6, 7, 8. Dos más. 9. One more. 10. Alrighty. Who is 7? You answered one yet?
Yeah.
Who is 5? You answered one yet?
No.
What do you got for me?
Platinum. 2.
Platinum 2
Oxide.
oxide. She right? Why not?
Because doesn't divide out, so it'd be platinum 4 oxide.
Would it be platinum 4 oxide? Remember, what's O's 99% of the time number? 2 negative, right? Well, how many O's do I have?
2.
I have 2 of them, which means I have a net 4 negative right there, right? Which means my platinum had to be a net 4 positive. Well, if I've only got one of them, That means it was platinum 4 oxide. Remember, it reduced out. So it was a 4, or it was a 4 and a, or a, yeah. Yeah, 4 and a 2, which reduced to a, oh no, it would have been, yeah, 4 and a 2, which reduced to a 1 and a 2. So it would have been platinum 4 oxide. Does that make sense? Okay. The easiest way to do it is to always start with the negative one. Always. That's why I said O is 99% of the time going to be a 2 negative. Start with this one. Do the math working backwards. Don't do the whole reverse thingy because of situations where they're reduced. Okay. Let's say I gave you this. Let's say I gave you Ca. No, let's do this one. I'm going to give you the name. We're going to go manganese 4 nitride. And I want you to give me the formula. Manganese 4 nitride, and let's go to 10 hands on this. Manganese 4 nitride. That's its name. I need its formula. What? People, it's a proven fact. Students who participate do a lot better in this class. There's some of you that I haven't seen raise your hands yet. So 2, 3. Four, 5. Go to Ted. 6. Come on, I need 4 more. 7. 8. 9, 10. Alrighty, who was 5? What do you got for me? Mn3 and 4. Is she right? Yeah, because manganese 4 meant I had Mn4 positive, right? Nitride comes from nitrogen. Nitrogen has a valence of 5. It's going to do what? It's going to gain 3 and become N3 negative. Drop and swap Mn3 and 4. So the rest of you that are not raising your hands, I need to know what we need help with. What are we not understanding? Yo.
So when you're getting the nitride number, that's from what it's going to do?
Yeah, exactly. Yep. So all I do is come over here, and that's a great question. So nitrogen is right here. And you'll see on this one, you can see that I actually wrote right above it, that group's going to be a 3 negative, as long as it's above the steps. This group's going to be a 2 negative. That group's going to be a 1 negative. That's because it wants to have a valence of 8. So nitrogen's a 5, it's going to gain 3, become a 3 negative, exactly. And that's always 99% of the time the case. Yes, Stratford.
If it's below the steps, what does it do?
Now, if it's below the steps, then it's the opposite of that, typically. But this goes back to what I was talking about earlier. I will tell you some of these and you'll just need to know them. Okay, so like we used to use this on the test and it made it easy. And then we went to the new one we're using, the one you have, and then I got a fight right here. A couple of boys fighting for that desk because it's easy to see, oh, that periodic table gives me the numbers. You know what I mean? We don't have that. I will tell you the ones you need to know. Now, the most common ones are these three: aluminum, zinc, and silver. They are all over here, but they all only have one number, which means they do not need a what? Roman numeral, right? And it's 70, we did the math, it's about 75%. So if it is in there, 75% of the time you need a Roman numeral. Okay, it was like, I don't know, 14 out of like 60 or 54 or something. Okay? And what I'll do is I will just go through and say, hey, you need to know that these 5 or 6 do not need a Roman numeral if it's one of those. And 3 of them, you already know: aluminum, zinc, and silver for sure. Silver is something we use all the time. Okay, does not need a Roman numeral because it only exists as silver 1. That's it. Okay. Zinc 2, and aluminum's aluminum 3. So they're for sure. I'll go through the test and give you the other ones you need to know. Okay, anybody else got a good question of what we're not understanding? Should we do some more or not? Yeah? Do one more? Alrighty, let's do name or formula? So you want me to give you the formula?
No.
Other way around? You want me to give you the name and you come up with the formula? Alrighty, let's do copper 2 carbide. Copper 2 carbide. So that's its name. I need you to give me its formula. Copper's number 29. Half the battle will be figuring out where carbide comes from. One, I need 10. 2, 3. Remember your numbers. 4, 5, 6, 7. It's better. 8, 9, 10. Alrighty, so Criddle. I believe you were 2, right?
Yeah, so I got CU4 and then C2.
CU4, C2. Stratford, you wanted to say something?
No, you have to like simplify.
Yep, so it would be CU2, C. Right? Copper 2 gave me Cu2 positive. Carbide is C4 negative. He did exactly what I wanted you to do, but remember, you must simplify. That makes sense, Criddle? But you were on the right track. Good job. Yo.
So because the copper was positive, for an ion, that, or the carbon had to be negative. So
It had to be. And you'll notice, and that happens, so down here, so what I did is if you look at this, it goes 1 positive, 2 positive, 3 positive, okay, 4 plus or minus. If it's above the steps, it's a minus. If it's below the steps, it's a plus. Do you see what I'm saying? And then 3 negative, 2 negative, 1 negative. And again, it just depends on where it's at. But if it's left of the steps, it's going to be a positive. If it's right of the steps, it's going to be a negative. Okay? Boron is an exception, but we don't spend a bunch of time with that. Okay? Alrighty. Time is yours. Use it wisely. I do have a couple of you that still have not figured out that the learn smart to do before the discussion. So there's 4 of you that I'll take them right now, or I won't take them at all.